Welcome everyone. Today we are going to discuss the topic projection of solids. Imagine designing a machine component, a building structure, or even a simple water tank. Before manufacturing or construction begins, engineers must represent three-dimensional objects accurately on a two-dimensional drawing sheet. This process is known as the projection of solids. In this presentation, we'll understand the different types of solids, their orientations, and the methods used to draw their orthographic projections. What is projection of solids? Now, let's understand what projection of solids means. A solid is a three-dimensional object having length, breadth, and thickness. Projection of solids is the technique of representing these objects on a two-dimensional drawing using orthographic views. The two principal reference planes are the vertical plane or VP and the horizontal plane or HP. The front view is projected onto the VP while the top view is projected onto the HP. Classification of solids. Next, let us see how solids are classified. Solids are mainly classified into two groups in polyhedra and solids of revolution. Polyhedra are bounded by flat faces such as cubes, prisms, pyramids, and tetrahedrons. Solids of revolution are formed by rotating plane figures, resulting in shapes like cylinders, cones, and spheres. Types of polyhedra. Now, let's discuss the different types of polyhedra. A tetrahedron has four triangular faces and is the simplest regular polyhedron. A prism has two identical parallel bases connected by rectangular side faces. A pyramid consists of one polygonal base and triangular faces meeting at a single apex. When the top portion of a pyramid or cone is cut by a plane parallel to its base, the remaining portion is called a frustum. Solids of revolution. Next, let us study solids of revolution. A cylinder is formed by revolving a rectangle about one of its sides. A cone is obtained by revolving a right triangle around one of its legs. A sphere is generated by revolving a semicircle about its diameter. These solids have curved surfaces and are widely used in engineering design. Position of the axis. Now let's see how the position of the axis affects the projection. Before drawing projections, the position of the solid must be fixed with respect to the reference planes. The axis may be perpendicular to the horizontal plane, perpendicular to the vertical plane, or inclined to one of the planes. The orientation determines the appearance of both the front and top views. Methods of projection. Next, we will discuss the methods used to solve projection problems. There are two common methods. The change of position method begins by drawing the solid in its simplest position and then tilting it to the required orientation. The auxiliary plane method introduces an additional inclined reference plane to obtain accurate projections. Although the construction differs, both methods produce the same final views. Worked example 1. Now let us understand the first example. Here, a square pyramid rests on its base on the horizontal plane with its axis vertical. Since the base is parallel to the HHP, its true shape appears in the top view. The front view shows the true height of the pyramid, and both views are aligned using vertical projectors. Worked example 2. Now let us look at another example. In this case, a cone has its axis perpendicular to the vertical plane. Therefore, The front view shows the true circular shape of the base, while the top view displays the triangular profile of the cone. Corresponding points are aligned using horizontal projectors. Conclusion, finally, let us summarize today's discussion. We learned that only two orthographic views, the front view and the top view, are usually sufficient to represent most engineering solids. Before drawing projections, the position of the solid must always be fixed. A face parallel to a reference plane appears in its true shape, and inclined axis problems are solved using either the change of position method or the auxiliary plane method. Thank you for watching.